Well, hi everyone. We're going to work on this third example, um, just on another video, this new video. When you're if you have a coefficient besides 1 here, I want you to factor out that coefficient. Inside the parentheses. So we're going to take the 1/2 out, x plus, and then half times pi is pi over 2. So we take pi over 2, divide by half, you're going to get pi. And just think, if you distribute that, you're going to have this. But we're going to we factor this out. It just makes it easier to look at the phase shift then in context of our old translation examples. All right, so with that, A is 1, the amplitude, non-amplitude thing is 1, the period is equal to pi divided by B, A is 1, B, and that is, if you take it divide by half, you're going to get 2 pi here, period's 2 pi. The vertical shift, which we have a vertical shift with this plus 3, is 3 units up. And then the phase shift, which is the same as the horizontal shift, is pi units left. Okay. So I'm going to just draw the cotangent function first. Let me draw that here. I have a vertical shift, so I'm going to kind of leave some room up there. And if you'll recall, the cotangent function, I'm going to do this part in pencil. You got 0, it starts at 0, and then you have a vertical asymptote and another vertical asymptote. So I've got a period here and a period here, and I'm going to put one over here too. Alright, and I'm going to kind of draw, cotangent doesn't start low, cotangent starts high. So draw and then come to here and come down. Here. We'll do this here. Okay. So that is the parent function of this. And I'm going to pay attention to the period because that's how I'm going to mark my asymptote here. And that is 2 pi. From 0 to 2 pi is 1 period. I'm going to cut that in half, that's pi. And cut that in half, and that's pi over 2. So that's kind of my increments that I'm going to use when we split the period into 4 parts. And then, so 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, which is 3 pi, 7 pi over 2, and 8 pi over 2 is 4 pi. This is negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Okay, so I got 3 periods drawn here. Alright, but we do have a phase shift, and it's pi units to the left. We're going to move all this way. We're also going to move it 3 units up, so we got to remember to do that. But let me first of all just get the asymptotes drawn more solidly now. Pi units, 4 pi down to 3 pi. This is the actual asymptote for our function now because I got to do this phase shift. And here's another one. Now this y-axis is being shifted pi units this way. And let me do here and here, 3 pi, 4 pi, negative 5 pi over 2, and negative 6 pi over 2. Okay. Now, we also have to move it 3 units up. And if I'm going 1 here, my a value of 1 and negative 1, I'll do that in a little more permanent way. 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3. All right, now we're going to take each one of these and move them 3 units up. So I'm going to kind of draw this line here, which is the midline of the cotangent function there. Oh, got to draw this asymptote here. I went out and scaled back to that, but I forgot to put it in. So I am now going to redraw this, each one of these, but in a more, I'm using ink on this part now, and I'm going to go like this, like this, and like this. Alright, let me highlight just to make sure we know the actual graph is not the asymptotes. The asymptotes help us, give us the guidelines and boundaries, what we need. But the actual graph is what I'm pointing out here in green that would satisfy this. Alright, so, and you could rewrite this as y equals negative tangent x by negative tangent, but if you check y equals negative tangent, that would flip it, and then 1/2 x, because it would go through the origin like that, and then plus 3, that you would get the same. These are equivalent functions because they would yield the same graph. All right, well, there's that example. God bless you guys.